Hey everyone, today's lesson is lesson 105 and it's using proportions to solve percent problems. So obviously we've used proportions a lot and we've done a lot of percent problems as well, but this one's different. This one is really, it's really kind of taking both of those things to the next level. The skill that you're going to practice today is a skill that I hope sticks with you forever. And it's a kind of a new trick. Up until this point, when we've been looking at proportions, we've really had them set up pretty easy, where we have a fraction over here and a fraction over here. And let's say you have one denominator that's 3 and one that's 12. You've been able to kind of look at these and ask yourself, well, how do I get from 3 to 12 multiplication wise? And you can quickly figure out, well, I need to multiply by 4. This is not going to be the case. They're not going to be set up quite so easy, but there is kind of a trick or a rule that you can follow every time, and it'll get you the right answer. And so this comes up in real life a lot. For example, like if I were to say, like, I went especially in shopping. So if I went shopping and I bought a new hoodie and it was on sale for $29, it was 40% off. Given that information, what was the full price of the hoodie? So using these strategies, you'll be able to find out information like that. So knowing this will serve you. Before I was a teacher, some of you know this, but before I was a teacher, I was the director of this salon and spa in Duluth. And when people would come in with big parties, they would leave just like one big tip for all of these technicians that they saw. And so I would have to look at the totals for services, like they got a massage and they got a haircut and they got their nails done and they had their makeup done. All of these different things, the totals for the services were different. So I created proportions, like what percent of this total tip should I give each technician based on the total of their service? So I used this skill all the time in my job. Just if you're wondering if you'll need to use this in real life, you will. So here we go. Using proportions to solve percent problems, we have, I think it's 3 different examples that we're going to do today. Our learning target is solving percent problems by creating a ratio box, setting up a proportion, and solving the proportion. So again, I've talked to you about ratio boxes. I myself really like them. They help organize my thinking. Use them as long as you need to. If that means forever, do it. You use them forever. If you don't need them forever, you can do some of this thinking in your head or just equation style. Here we go. This is just a quick note, reviewing percents. So, for example, you don't have a problem in front of you, but this is just a brief statement. If 40% of the vehicles were cars, we know that if we're given that information, anytime we're talking about percents, we're talking about something out of 100. Given 40% were cars, we can assume that 60% were not antique cars or were not cars. And again, just at the bottom here, you can see we can write 60% as 60 over 100. It's just a few brief notes. Let's take a look at an actual example here. So here's where they got the thing about the cars. You get that whole thing in there? There. Okay. 30% of the cars in the parade are antique cars. If 12 vehicles are antique cars, how many vehicles are in the parade in all? Okay, so this is our first example. If you want to go ahead and pause the video right here and give this a try completely on your own, go rogue. Just totally do it. Go ahead. Go ahead and pause the video. See if your answers match with mine. If not, go ahead and stick with me. This is the first time we're setting up a ratio box today, so it might just help to at least see this first example, have me walk through this first example, and then try a few on your own. So as we're setting up this ratio box, we're going to fill in some information that we know. So right away it tells us, let's get my pen here, 30% of the cars in the parade are antique cars. So I don't know, I'm going to use A for antique cars, and they told us 30% of them were antique cars. If 12 vehicles are antique cars, okay, so that's also a piece of information, the actual count is 12. How many vehicles are in the parade in all? Well, look at all those other empty boxes. We have to kind of use what we know and assume the stuff that we don't know. So percents are always out of 100, right? I'm going to make this a total line and fill in 100. If 30% are antique cars, I don't know, let's call this not antique cars. NA. 100 minus 30 is 70. That would mean 70% of the vehicles in the parade are not antique cars. I was wondering where I got that word vehicles. I thought I saw it up here. Vehicles. That's probably going to be our label. Okay, so looking at this, we're going to use this information to set up a proportion. I took some quick notes here. Yeah, okay, so I like this. So 30%, we can write that as 30 over 100. And we're comparing that to 12 actual cars. This is our unknown here. I don't know. We'll call it X. Okay. So we have a proportion here. We're looking at the two pieces of information that we know. We have 30 and 12. So 12 isn't a factor of 30. They have a common factor, but 12 in itself is not a factor of 30. So that's not a quick, easy transition there. We can't say like 12 times 2 and make it a quick, simple multiplication problem. In a case like this, here's what you do. This might seem confusing at first. I'm going to do my best. I wonder, I might even zoom out a tiny bit just to allow myself a little bit more writing space. Oh, here I go, writing all over the paper. I'm going to show you what you're supposed to do. In a case like this, you can always do this. And this is going to definitely be applicable in your 7th grade math and 8th grade math. You're going to do a lot of these. So what you're going to do is look at the two pieces of information you have at a diagonal from each other. So looking at the proportion I just created over here, where you see 30 over 100 equals 12 over X, looking at a diagonal, the 100 and the 12, we're going to multiply those. So I don't know. If I do this step by step, I guess, oh geez. Here we go. We have 100 times, oh, I can't do a dot. 100 times 12. So I'm multiplying these right here. You multiply those and divide by the one that's left. That's it. That's the rule right there. You multiply the ones across from each other and divide by the one that's left. I'm going to tell you what, making a divide symbol is like literally impossible because I can't make a dot. So that's the best I can do right now. So we have 100 times 12 divided by the one that's left, and that's 30. Yikes. Okay, so I'm actually going to, I'm going to zoom a little bit more, get a little bit more writing space, and I'm just going to keep working kind of down here. 100 times 12 is 1,200. And I still need to divide that by 30. We can make pretty simple division here by crossing off. We have 2 zeros on the ends. Now we have 120 divided by 3. And I ask myself, well, what's 12 divided by 3? That's 4 plus an extra 0. We get 40. So 40, now we have an answer, but we need to go back and look at what kind of label we need. Go back and double check by rereading their exact question. What are they really wanting us to answer? The final question up here is, how many vehicles are in the parade in all? So, how many vehicles are in the parade in all? So right here, this is where we're filling in. 40, our label is vehicles. Oh boy. Sorry, you guys. That's supposed to say vehicles. This is ridiculous. But 40 vehicles. All right. You've given that a try. Let's try another one. I'll zoom in a little bit. Set up a ratio box if it's helpful. If not, that's okay. Go ahead and pause here and solve on your own, and unpause it when you're ready. When I go to solve this, 40% of the team members played in the game. If 24 team members did not play, then how many played in the game? Okay, so we have, I'm going to set up a ratio box. I don't know, 1, 2, 3 lines, and then here, and we have the percent and the actual numbers, and I have, I'm going to say players, and then those who did not play, and then a total box down here. Fix that P. 40% of the team members played in the game. 40% played. Okay. 24 team members did not play. So that's another piece of information that we have. 24 did not play. Again, we know that percents are always out of 100. We can fill that in. And if we know that, then we know our missing box here, that's 60%. Looking at this ratio box right here, let's just double check and find out what exactly are they asking us to solve. How many did play? So really, this is our X now. This is what our unknown is. This is what we need to solve. This is algebra, so I love it. So here we go. Actually, if we look right here, there's our proportion. There it is, right in front of us. We just have to rewrite it in a way for us to solve. So literally we have 40 over 60 equals X over, that's a weird X over 24. And again, our first step is to multiply the two pieces of information that are diagonal from each other. So we're going to multiply the ones at a diagonal and divide by the one that's left. So here we have 40 times 24, and we're going to divide by the one that's left, divided by 60. These are really big digits. I don't know these facts off the top of my head, and for time's sake, so you're not sitting here while I'm doing tons of math, I'm going to cross-reduce. It's just a good thing for mathematicians to do. It saves you a lot of big math. So let's just first look at, let's look at the 24 and the 60. Both of those have a factor of 6, right? So 60 divided by 6 is 10. 24 divided by 6 is 4. We don't have to stop there, though. I can actually now use that 10 to cross-reduce with our other big number over there. We have a 40 and a 10. I can reduce those again. I can, because these are all broken apart, I can actually cut off a 0 off of each of them because it's on the end. So I have a 0 I can cross off on the end here, a 0 I can cross off on the end there. I've ran out of room again. I'm going to try to zoom out, scroll a little bit. Come on. Okay. Pen again. Okay, so now this looks really messy, but now I have a 4 times 4 on the top divided by 1. Well, okay, so let's start with that. 4 times 4 on the top is 16 over 1. Anything over 1 is 16. We've reached an answer of 16, but now we need to figure out what exactly is our label. How many did play? I would say 16 played. Ugh, yikes. 16 played. Yeah, okay. Let's try another one. Go ahead and pause it. Give it a try on your own. So when I'm looking to solve this one, again, I'm going to set up a ratio box. Buying shoes on sale. Oh, so this is kind of like my hoodie example. Buying shoes on sale, Natalie pays $45.60, which was 60% of the full price. What was the full price of her shoes? Okay, let's set up a ratio box. We have the percents and the actual. And then what are our labels? So buying shoes on sale. I don't know. Paid, saved, total maybe? I don't know. Something like that. I did take notes on this. I just want to see what I wrote earlier. Total, that could also, on my notes, I wrote full price. That might make more sense. So, she paid, I don't know what's up with that word. She paid $45.60. Okay. Can't make a decimal. Sorry, that's supposed to be a decimal. And that was 60% of the full price. So 60%. Full price would be 100%, right? No discount at all. So if she paid 60%, that would make this box 40%. That's the missing piece. What was the full price of the shoes? So this is our X. This is what we're wanting to know. We don't really, even though this is part of our ratio box, it's kind of irrelevant. They're not even asking us to solve that. So here's our proportion, you guys. We have 60 over 100. Do you see where I'm getting that? I can cross out that middle box. The x is what they're asking us. The x is what they want us to know. If you look at this here, we have 60 over 100, 45 over x. 4560, excuse me, 4560 over x. That's, again, my decimal. Okay, so I'm going to zoom out a little bit, get myself some more room. Uh-oh. Oh, no, I'm losing connection. I don't know if I'm still recording. And my lights literally just turned off. Ugh. No, no, no. Dang. Okay. I think I'm still recording. If for some reason you haven't turned off this video yet, thanks for hanging out with me. Sorry about that. It's dark, so you can't quite see me as well anymore, but let's just finish up this example so I don't have to redo the whole video. Come on, let's go. Oh my goodness, this is just crazy. Let's go. Okay. I don't know what's happening here, but we're going to try to keep going. So again, we have 60 over, might not let me write, 100 equals 4560 over x. So we're going to multiply the numbers that are across from each other. So this 4560 times 100. We can actually do that in our heads. When we have a decimal number and we're multiplying by a power of 10, we can just shift our decimal to the right, however many spaces of zeros we have in our power of 10. So if we're multiplying by 100, 100 has 2 zeros in it, we're going to bump our decimal 2 times. So instead of $45.60, now we have I'm not even going to do the dollar sign right now. We're just going to do 4560, no decimal, all over 60. To save ourselves a little bit of math here, I'm going to cross off the zeros on the end. We have 456 divided by 6. Oh, brother. Here we go. 456. 6 couldn't go into 45. 7, 42. Yikes. 3, 6, 6. That didn't turn out very well, but that's 76. They're asking what was the total price of her shoes. Make sure you use the correct label. They're asking about a price. We're talking about money. $76. In this case, of course, money, your dollar sign is your label. Oh boy. That's it. That's all of our examples for today. You have a homework assignment uploaded to the same file in Google Classroom. Thanks for watching and bearing with me through that loss of power. Have a great day.